All right, here we go. Let's multiply these terms and see what we get. So I've got the quantity 4x minus 8 times the quantity 4x plus 8. Now this is what we call, this is a special case. This is what we call the difference of squares. And so that formula is ax plus b times ax minus b equals ax squared minus b squared. I suppose I could have wrote that out, but that just doesn't have the same appeal like that, huh? All right, let's get rid of it. Let me write it out. So it looks like this: ax plus b times ax minus b is equal to a squared x squared minus b squared. Actually, you don't even need to write the x's. In this case, you do though. So, but let's multiply it out and see what we get. So I'm just gonna say 4x plus 8. In other words, I could tell you what the answer is. This is going to be 16x squared minus 64. You're like, what are you, some sort of wizard, Mr. Adams? Yes. And let me show you what's 4 squared? 16. What's x squared? X squared. What's 8 squared? 64. But let's go through it. Let's crank through and do this anyways. 4 times 4 is 16. X times x is x squared. 8 times 4x is positive 32x. 4x times negative 8 is negative 32x. And then negative 8 times positive 8 is negative 64. I forgot to write down the 2. My brain thinks faster than my hand can write stuff down. So what happens here is that this cancels with this, right? 32x minus 32x is just 0. So I'm left with this answer. But this is called the difference of squares. And so there's two or three special terms that you can memorize these patterns, but this one's called the difference. And it comes up quite a bit of squares. Because the first term is a square, and then you're subtracting another square. In other words, this is a square, right? And this is a square, and you're subtracting them. So it's a difference of squares. And that pattern is really, you'll see it sometimes in some textbooks written as a plus b times a minus b, and that would be applicable as well. Okay, any questions on that one?